All right, we're jumping into chapter 2 where we're talking about descriptive statistics, which is how we describe data, right? We organize it and we present it to others. We're going to start with types of graphs. And we're going to look at several different types. Each of those types belongs with a very specific type of data. So how you select the plot depends on which type of data that you're graphing. We're going to start with stem and leaf plots. Stem and leaf plots are common when we're looking at quantitative numeric data. Mostly when we're looking at discrete, very common, like in this example, you can see we have discrete countable whole number data. You do sometimes see it with decimals when the decimals can be cleanly divided by their leading digits. But most common, again, with quantitative discrete, those nice pretty whole numbers. And the reason these are called stem and leaf plots is we take these numbers and we divide them into two pieces. So for example, the first data value here is a 32. I'm going to take that number and divide it into two pieces. I'm going to separate the last digit from all the other digits in the number. So I'm splitting that up. This last digit is what we call the leaf. Everything to the left of that line over here, in this case it's only 2 digits, so it's a 3, but if there's more over here, this whole chunk over here is called the stem. And when we make our table, we're going to make two columns, one for the stems and one for the leaves. And we group the numbers by stem. So when I'm looking at these numbers, I see my smallest is 32, my biggest is 61. So if I'm cutting these numbers in half, the smallest stem I have is a 3, the biggest stem I have is a 6. So I need rows in my table for each of those. 3, 4, 5, 6. For the leaves column, I want to write the leaves in numeric order from smallest to largest, and I need to include any repeats. So for example, when I look at the section of 40s, I see 48, 48, 48. 48 shows up 3 times. In my row of stem 4, I should have 3 8s. 1, 2, 3. What I want this stem plot to do is show me the shape of this data by looking at the length of the rows. And so I need to account for those duplicates so that the rows are the appropriate length. So let's go ahead and do that for this data set. So I'm going to split this up by number. So there's my 30 stem, my 40 stem, my 50 stem, my 60 stem. And we're just going to go number by number. So I see a 32, a 32, a 33, a 34, and a 38. And then I'm going to repeat this process. So you might want to pause the video and do this on your own and check that we get the same graph. So for 40s, I see a 0, a 2, 2, 3, 4, 6, 7, 7, 8, 8, 8, 9. Make that longer. For the 50s, I've got a 50, 50, 51, 2, 2, 2, 3, 4, 6, 7, 7. And then for 60s, I have a 60 and a 61. And that is a stem and leaf plot. I can see the shape by looking at the rows. This graph is heavier in the 60s and or 30s and 34s than it is in the 50s and 60s, right? There's more data in the lower half of this table than there is in the upper half. We call this slightly skewed. And we'll come back to that term in a little bit. The nice thing about stem and leaf plots is if I needed to reconstruct my original list of data, I could do that from the table. 32, 32, 33, 34, 38. The other thing that's nice is if I wanted to compare the Park City basketball team to another basketball team, all I would have to do is add a set of leaves over here to the left for the new basketball team and then build outwards towards the left instead of towards the right. 0, 2, 4, out to the left. So I can do stem and leaf for a single table, or I can do a two-sided stem and leaf, sometimes called a double-sided stem and leaf, or stem plot, to compare. Really advantageous because I can get the data back from the table. All right, our next type of graph is a line graph. Line graphs are also done with quantitative data. You'll notice here we have a frequency table where my class represents the number of times in the shop. My frequency is the count. So for people who are asked how many times per year they take the car to the shop, people who didn't take their car in at all, that's 7. People who took it in once, that's 10, and so on. For a line graph, we take the class and plot it on an x-axis, the frequency on a y, and then we connect the dots. So I'm going to zoom out so we can see what we're doing with that data. So I want to construct an x and y axis, and I know that my x-axis needs to go from 0 to 3. My y-axis, the smallest value is 7. The biggest is 14. I need to go all the way up to 14. So I'm going to count by 2s. I'm going to start my axis right here, and that would be 2, 4, 6, 8, 10, 12, 14. So that gets me all the way to the top there. And then 1, 2, 3. And my next step is to add dots to the table. So my first ordered pair is a 0, 7. So on the x-axis I go to 0, and then y says I go up to 7, which is halfway between 6 and 8. My next one is 1, 10, 2, 14, and 3, 9, which is halfway between 8 and 10. And it's called a line graph because we actually do play connect the dots here. So we're going to draw straight lines between each pair of points. And you'll notice this is a little different. If you're in physics class, you shouldn't do this with data, right? You don't typically do line graphs. We want smooth curves in those classes. But for statistics, when we're looking at frequency tables like this, where I have one variable, which I should label number of times in shop, yeah. And then on the y-axis, I have frequency, which is just a count. line graphs are well suited. This is different than having two different variables, number of times in shop and number of cars owned. It's two variables. It's a different type of graph, and we'll see those towards the end of the semester. All right, next type of graph, bar graphs and pie charts. These I'm assuming you're probably very familiar with. Bar graphs are one of the first types of statistical charts that you see like in high school and middle school. They are what they sound like. We make bars for each category because these go with categorical data. For this example, we can see we have another frequency distribution. They've given us a class, which is age groups. And notice that they've done that with words instead of numbers. So this is categorical data because I don't know what numbers go with children versus working age adults. So this is a categorical variable. They've given me a frequency. Remember, frequency is just count or number. And then they've given me a percentage, which I know is relative frequency. For bar graphs and pie charts, typically we use one or the other. So bar graphs can use frequency or relative frequency. Pie charts will always use relative frequency. You should know how to construct a bar graph. I'm going to do a pie chart for you, but I'm not going to ask you to do it on your homework. Let's start with a bar graph. So for a bar graph, I need an x-axis and a y-axis. And I have two things I'm plotting, class and frequency or class and relative frequency. Here you'll notice it specifically says construct a bar graph showing the proportions, and they mention proportion as percent. So for this bar graph, I'm going to do relative frequency. So one axis needs to be class, one axis should be relative frequency. And I get to choose. For bar graphs, it doesn't matter. I prefer my bar graphs vertically, so I'm going to put that age group down here on the x-axis, and I'm going to put the relative frequency on the, or in this case they called it proportion, on the y-axis. You could flip these and you would get a horizontal bar graph, and that would be okay. For bar graphs, we want bars that are separated by a space, and I typically want the gap between the bars to be about half the width of a bar. So I'm going to do children, and then a gap, and then working adults, and then a gap, and then retirees. And just short labels, child, worker, retire. For the y-axis, I then need to figure out proportions. I'm counting, my lowest is 19, my biggest is 43. So let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45. That'll work perfectly. All right, so we'll count by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay. And then all we're doing is plotting those points. So looking at children, that's 19, just shy of 20. So I know the top of this child box should be just about here. Mine's being a little finicky because I'm using digital to do this. There we go. Because I'm counting by fives and it's not exactly clear that that's 19%, you can write that y value, that frequency or relative frequency, above the bar or next to a horizontal bar if you want to make your graph extra readable. So I'm going to do that for this graph. My next row is workers. I can see for working age adults that's 43. So middle workers is up here somewhere. And then my last bar, retirees are at 38. So middle of retirees, 20, 30. Oh, this is my 38. Mr. J. Brownie face. I'll move that this way. .43 should be above 40, not below 40. Be right about here. There we go. Some notes about how this was drawn. Notice consistently I've been labeling my axes with the appropriate labels. That's super important when you're drawing statistical graphs. The other thing to keep in mind, notice my lines are nice and straight. I'm cheating, right? I'm on an iPad, so when I click and drag, it automatically does a straight line. If you're doing this on binder paper, make sure that you're using a ruler. The other option is you can do this in Google Sheets or Excel if you know how to use a spreadsheet program, and that's also an acceptable solution. My hope is that that doesn't feel too scary. Again, you'll notice the bars are equal width, 2 boxes, 2 boxes, 2 boxes. The space between the boxes is about half the bar width. The bars don't touch. The nice thing about bar charts is they compare the bars to each other. Pie charts compare the chunks to the whole. And I don't know how neatly I can do this, but I will try and do this for you. We will see. Technology is sometimes nice. Center is about here, I'm assuming. So with a pie chart, what I want to do is slice up that pie into appropriate percentages. And I know that if I'm looking at a circle, an entire circle from 12 o'clock at the top all the way around back to 12 o'clock, that's 360 degrees. So what I want to do is take that 360 degrees and split it up by this percentage. And so to do that, we're going to take those percentages, turn them into decimals, move the decimal place over 2, and then multiply by 360. So let me grab a calculator off to the side here and do that really quick. So I get, for this first box, I get that that's 60, not 36, 68.4 degrees. And then for the next one, we have 0.43 times 360, which is 154.8. And then the last one is 0.38 times 360, which is, whoops, oh, that's a typo. Try that again, Mr. J. 136.8. You will notice that when I started this pie chart, I started that baseline that I'm going to measure from at the top, pointing at 12 o'clock. I'm going to measure clockwise, just like I would read an analog clock. And typically when we do this, we plot them in order from biggest section to smallest section. So I would actually do working adults first because that's the biggest percentage, and then retirees, that's the next biggest, and then children would be last, that's the smallest. And I would get a protractor and I would line it up with that 12 o'clock and I would measure out 154 degrees. I'm going to estimate here because I have an idea of what 154 looks like, just based on teaching trig for so long. I know that's about here. And so this would be 43%, and that represents the working adults. From this line, I then measure around the next chunk, which is 137 degrees this way. And that's another one that I'm going to kind of estimate. And that should be about here-ish. %38 represents the retirees. And because I only have a third category, I know that this must be my 19% for children. The trick with pie charts is you either need to be really good at estimating percentages and angles, or you need to have a compass handy. So these are not typically something that you would do by hand. They are a time investment. These are better to do by pie chart. Or pie chart. Spreadsheet. Words are hard. Spreadsheet. All right, that's enough for this video. We're going to pause and come back. In the next section of types of graphs, we're going to start with histograms, which are another type of quantitative graph.